Okay, inverse variation. So we've got direct variation and inverse variation. So an equation that can be written in this format, y equals kx. K is just going to be a number. So it might say y equals 2x or y equals 3x, something like that. This k number is called the constant of variation. Okay, and that also appears in inverse variation. It's just that the equation's a little bit different. Instead of y equals k times x, this would be y equals k over x. So it might be y equals 2 over x or something like that. Okay. Also, you can rewrite these equations. If I wanted to solve this, say for k, that you're going to you could solve it for x, but sometimes you're going to see this. Maybe a little more common is this solved for k. If I wanted to solve this for k, I'd divide both sides by x. So k here is going to equal y divided by x. That's equivalent, right? And we can do the same kind of thing over here. If I want to solve this for k, then I'm going to multiply both sides by x. And then k would equal x times y, yx or xy. Okay. All right. So this first batch of problems, I just want to figure out, do these equations fit into one of these formats or not? Maybe they don't. Okay. Are the following relations direct variation, inverse variation, or neither one? Okay, so this first one, I've got xy equals 3. So that is, I'm thinking this, right? I don't have a fraction here, but remember, if you solve for y, then I would divide both sides by x, right? So y is going to equal 3 over x, and that does fit in this format, right? So this one is going to be inverse. So if you can recognize it without transforming the equation, that's fine. But this one is definitely going to be inverse variation. Okay? So it maybe is a good idea to always solve these for y. This one's already solved for y, so I can see that this is going to be direct variation. I'm not going to write out the word variation every time. That one's direct. Okay. Now this one is pretty similar, except I've got this plus 1. And notice in both of these formats, there's nothing added or subtracted. So this is going to be a disqualification, even though without that, this would be direct variation. But with the plus 1, that's going to be a disqualification. Okay. This next example, I have an XY table. So what I want to do is think about the relationship between the x's and the y's. And this is where it's really going to come in handy to look at the ones that are solved for k. So what I want to know is, if I take my y divided by the x, do I get the same thing out every time? Or if I have the x times the y, do I get the same thing out every time? So I'm looking if this relationship is going to be true with each ordered pair. Okay, so looking at let's check this for direct variation. Here, let me separate this one here. So I'm thinking, is this direct variation? Well, if it is, then k is always going to equal y over x. So I want to think, well, 8 over 3, and then I'd have 6 over 4, and I'd have 3 over 8. And I want to ask myself, are those really all equal? And they're not, right? All of these are, well, this one's not reduced, but the other two are reduced. And I can see these are not equal to each other. So it's not going to be direct variation, okay? And that doesn't necessarily mean it's going to be inverse. It could still be neither, right? Because I've got 3 options. So I want to check now inverse variation. I'm going to use the k version. So let's think about this. And if this doesn't work, then I'll just say neither. But I'm thinking, do I get the same thing out every time when I multiply the x and the y together? So let's see. 3 times 8 for my first xy pair, 4 times 6, and then 8 times 3. And those all equal 24. So those are all equivalent, and so that means I have a winner here. This one is inverse variation. Okay. All right. on to the next type of problem. So this one is telling me that I have direct variation. Okay, so direct variation, I'm thinking, okay, the basic direct variation formula is y equals kx. I'm going to be starting with this. Okay, so first step, choose the correct formula. Well, that one's direct, so I use this. And next up, I'm going to plug in x and y to find k. Okay, so I've got an x-y pair here. What I'm going to do is substitute them in. So y is 18 when x is 6. And hey, now I can solve this for k. I just divide by 6, and k is going to equal 3. Okay, now that I've got that, now I'm going to write the equation by substituting in the k value. Now that I know what k is, okay? So I'm going back to this and I'm thinking, okay, well now I can write y equals 3x. In other words, the y's are going to be 3 times as big as the x's. Since this is direct variation, it's always going to hold that same relationship. Okay, on the next page, let's try an inverse variation problem. So I can see, oh, it says that this is inverse. So my starting place then, without even reading the rest of the question, I know I'm going to be dealing with y equals k over x. Okay, so I want to substitute my x-y pair into this so that I can solve for k. So y is 10 when x is 2. Okay, and then I'll multiply both sides by 2. To isolate the k, k is going to equal 20. Okay. Now that I've got k, I can go back to my equation and I can rewrite this direct variation equation to make it fit this particular problem. Y is going to equal 20 over x. And there we go. There's the equation. Okay. So we're going to take this one step further on the next type of problem. So pretty similar type of problem. This one's direct variation, so that's different. But on these 2 previous problems, we were just writing the equation. Now this is asking me to find one of the variables. So I'm still going to want to write the equation first, and then I'll use that to find the unknown. So steps, use the known pair to find k. That's the same thing as we were doing up here. Okay, now this is direct variation, so that's different, like I was saying. So make sure you choose the right formula. I'll plug in the known pair. By the known pair, I mean, that's just my terminology. I know that x-y pair, right? I know both of them. So I'll call this the known pair. And this one, since I'm missing the x, I'm going to call that my unknown pair, just for clarification, so you know what I'm talking about. Okay, so I'm using the known pair because I can plug in 9 for y and 5 for k. This is not always going to be an integer. The k here is going to equal 9/5, and that's okay. So I got a fraction. Okay. Now I'm going to rewrite this equation. So this is, I found k, right? Now I'm going to rewrite the equation. Y is going to equal 9/5 x. Okay. And now the last step, I'm going to use the unknown pair to solve for x and y. So now that I've got this equation written, I'm going to plug into that. I'm going to plug in the unknown pair. So I'm going to plug in 13 for y, and I'm not going to plug in anything for x. I'm going to leave x as x. I'm going to solve this for x. Okay? So I want to isolate the x here. You could multiply the whole equation by 5, then divide by 9. That's totally fine. I like to just multiply by a reciprocal when I need to get rid of a fraction, because 9/5 times 5/9 would give me 45 over 45, which is just 1, right? So those will take care of each other. And now over here, this is going to be, that's a 13, not a 3. So 5 times 13 is 65. I'm going to get 65 over 9. Okay, and I'd want to make sure that's reduced, which it is. It'd be 7.2 repeating if you wrote it as a decimal. I'm just going to leave it like, well, you could write it either way. I don't really care. Okay, so there we go. That's what x is going to equal and y is 13, assuming that this is direct variation with that known pair. Okay? All right. Oh, sorry, I was off screen there a little bit. Okay, so let's try one more. Same kind of problem, except now we're back to inverse variation. Okay, so my starting place then is y equals k over x. I'm going to plug in the known pair, right, into that. So I'm going to plug in 7 for y and 4 for x. Okay, and then I'll multiply both sides by 4. So k is going to equal 28. Okay, I'm going to plug that into the equation here. Now I've got this equation, and I'm going to plug the unknown pair into this equation that I've written now that I have the k value. So y I don't know, but x is going to be -5. Okay, and actually this one the y is already isolated, so I just make sure this is reduced, which it is. So you could leave it like that, or you could, let's see, that's going to be -5.6 as a decimal. Either way is fine. Okay, and that's it for today. See you next time.